data becomes the modern currency, so the ability to quickly and accurately analyze that data has become of paramount importance. One of the most flexible and increasingly powerful tools at our disposal is Excel. Since the late 90s, Microsoft has been adding analytics functionality, and Excel now offers some fairly potent tools for doing data analysis. These include more effective tools for cleaning and transforming text data, functions for performing those tricky date calculations, and tables which enforce greater data integrity and help automate the effect of changes to the data.
In this course, we will delve into these new tools as well as covering the long-standing data preparation, aggregation, logical, and lookup functions. Over 5 weeks, we're going to walk you through a practical case study seen through the eyes of Zara from the accounts department of her firm. She is responsible for the monthly reconciliation, but the data she receives from their supplier is problematic and not compatible with her own system data. We will help Zara develop a solution that not only addresses all the issues with the data and largely automates the reconciliation, but also offers a solution that is fully reusable in the future.
These are the topics we will cover. In week 1, we will focus on text functions for cleaning and manipulating text data. Week 2, we're going to look at date functions for working more effectively with dates. Week 3, we're going to explore named ranges, a way of simplifying calculations and helping automate processes. Week 4, the focus is tables for more effective and automated data management. And week 5, we look at logical lookup functions for categorizing, linking, and decision-making.
Regardless of what sector you are in, this course will give you a solid grounding in the fundamental Excel analysis tools to equip and empower you to get on top of your data and accelerate your data analytics. Our previous Coursera specialization, Excel Skills for Business, has been rated highly at 4.8 stars out of 5 and impacted over 100,000 learners like you. In this specialization, we focus on Excel skills for data analytics and visualization. Join us on this exciting journey. So to summarize, these are the topics that we'll be covering this week. Functions for combining text, functions for splitting text, combining text functions, cleaning data and changing case, removing and replacing unwanted characters. Each topic has a great training video for you to watch, and you will get a lot more out of them if you follow along in the practice workbooks provided. There is a workbook for each video, but you can keep working in the same workbook from the previous exercise as long as you've completed all the activities. After each video, there is a quiz for you to test your knowledge, and at the end of the week, we have a practice challenge for you to practice all the amazing new skills that you have learned. And now, it's over to you.
In this video, we're going to look at a range of Excel functions for taking data from 2 or more sources and combining them into a single cell. In our scenario, Zara has received a statement from the supplier detailing all the invoices that have been paid this month. She needs to reconcile this with her system data, which she has downloaded into an Excel file. The problem is, a lot of the data doesn't match. So for example, with her system, the payment reference is made up of the invoice number and the payment number. On the supplier statement, however, this data is in 2 separate columns. Before she can actually compare these values, she's going to need to join the document number and the payment number. She's created a column in which to put the new value, and we're going to help her do it using Excel's concatenate function. Start by clicking into K2 and type equals CONC. If you have 2016 or later, you will notice there's a brand new concat function, which we'll look at shortly. But the concatenate is still widely used. And if you don't have 2016 or later, you're still going to have to use this. You'll notice a strange little chevron here. It is actually being made redundant, so it's still being kept for backward compatibility. But if your organization is on the newer version, you probably want to start moving to the concat function. But let's see the concatenate first. So to select it, you could double click, but I'm going to down arrow and Tab. Now, whenever you use an Excel function, it will give you a help prompt explaining what things or arguments need to go in the brackets. In the case of the concatenate function, we just comma separate all the text values we want to join. So we're going to start by clicking on the document number. The next thing we need is an underscore. We're going to put a comma, but if you just type underscore, you will get an error. With Excel functions, wherever you want to reference something that's not a cell reference or a number, you must put it in double quotes. So we're going to open our double quotes, type our underscore, and close our double quotes. We're then going to type another comma and select our payment number. You can use up to 255 arguments in a concatenate function, but we only need 3, so we're going to press Enter. And there's our payment number. Now, to copy that down, we're going to click back onto it, and the best way is to use the fill handle, which is the small green square in the bottom right-hand corner. You can drag it. The only problem is with a big data set, that's going to take a while. So an even quicker option is to come to your fill handle and double-click. That will copy it down to where the data on the left stops. It only works vertically, but it is really quick. That was our concatenate function. But there's another alternative which is also available in all versions of Excel, and that's the concatenate operator. It's a little easier and a little more versatile. So let's see how we could join our 3 bank numbers together using the operator. Now, an operator is a bit like a plus rather than a function. So we type our equals and then we just click on our first value and type ampersand or and. So we want our ABN and our account and our check digit. Really easy, and when we press Enter, there's all the numbers joined together. The only problem with both the concatenate operator and the concatenate function is these 3 values are all sitting next to each other, and yet we have to select each one. Whereas most functions will allow us to just highlight the range. Well, that's what the new concat function gives us. If you have the newer version, do this with me. We're going to type equals, CON, and select concat. We're now going to highlight our 3 numbers. So starting from H2, drag to J2, and press Enter. This also gets us around the limitation of 255, as long as the numbers are all next to each other. So a few advantages there. One last option we're going to look at is text join. This is a new function as well, but it has 2 great features that the others don't offer us. So we're going to use our bank numbers again. I'm clicking into L2 and I'm typing equals, TE, down arrow, and tab to select text join. The first argument it's offering is a delimiter. This is a separator. So if I had a whole bunch of names and I wanted spaces between them, I could use space as my delimiter. In this case, I would like a hyphen between each set of numbers. So I'm going to open my double quotes, type my hyphen, close my double quotes. Then a comma, and now it gives me another argument, which is the option to ignore empty cells, so I wouldn't get 2 hyphens next to each other if I was missing one of the numbers. In this case, it doesn't matter, but I'm going to say true to ignore empty cells, and then type a comma. And now it's much like the concat. I can either individually select my items, or I can highlight the whole range. And when I press Enter, there's my bank details separated by hyphens. So really, really efficient function. Let's copy this one down. So back onto L2 and double-click our fill handle. So 4 options we looked at there: the concatenate function, the concatenate operator, the concat function, and text join. For your optional homework, try and create these bank details with the separated hyphens, but using the concatenate operator. The solution file will have that solution so you can check that you've got it right. In this video, we're going to look at some Excel functions that will allow us to split text data, namely the left, right, and mid functions. So Zara's next task is to find out which month each invoice was raised in. What she basically needs to do is extract the first 3 characters from the invoiced column. And to do this, she's going to use Excel's left function. So we're going to click into M2 and type equals LE and tab. The first thing the left function needs to know is the original text that you want to split up. That's our invoiced value in D2. Then we type a comma. The next thing the left wants to know is how many characters do we want to extract from the left of that text in D2? And the answer is 3. Press Tab to jump to the next cell, and there's our March. The next thing Zara wants to do is get the purchase order number on its own. At the moment, the purchase order number is joined to the location in the customer purchase order column. So this time we want to extract 6 characters from the right. And yes, we're going to use the right function. So in N2, type equals RI and tab to select right. Our text this time is G2, type a comma, and we need 6 characters. And again, let's press tab to jump into O2. And there's our purchase order number. The last example we're going to look at is we want to get the location, which is also in the purchase order number. To keep it simple, we're just going to return an S for Sydney and an M for Melbourne. But you'll notice the location is not on the left and it's not on the right. It's actually in the middle. So for this one, we're going to need to use Excel's mid function. In O2, start by typing equals MI and tab to select mid. The mid function has 3 arguments. It starts with the text, so we're going to click on G2 and type comma. But now, because it's not starting at the left or the right, we need to specify a start position. And the start position is actually position number 4, which is where the first letter we want begins. So we're going to type a 4 and then a comma. And now it's like the left and the right. We specify how many characters we want to get from that position. And the answer is 1. If we press enter, there's our S for Sydney. And we can now copy all 3 down. So I'm going to select M2 to O2, come to my fill handle, and double click to copy down. So to recap, the 3 functions we've looked at for splitting text data are left, right, and mid. These examples were all fairly straightforward, but in the next video we're going to look at how we can solve slightly more complex problems where the data we want to extract isn't necessarily the same length. In this video, we're going to look at how we can combine Excel functions to get even more power and solve those more complicated problems. In the last example, we used a mid function to extract the first letter of the location. Zara really needs the full name though. The only problem is that Sydney is 6 letters and Melbourne is 9 letters, so she can't just type a 6 or a 9 in here. She needs Excel to calculate that length for her. The good news is that Excel is very good at working with patterns, so as long as there's a pattern in the data, it can probably help. If you had data that was all lowercase Mickey Mouse, although our brains could immediately split that, there is no pattern, it's all lowercase, Excel can't help us. But with our customer purchase order, there are a couple of fairly obvious patterns. You'll notice, for example, that the location always has 3 characters before it and always has a hyphen after it. So if we can just locate the position of the hyphen, we can work out how long our location is. And this is exactly what we're going to do using Excel's find function. I'm going to start by doing the find on its own, and we'll just borrow the type column for this. So in P2, we're going to type equals fin and tab. What the find does is find a string within another string and return the position at which it starts. By default, it will return the first instance it finds, but we'll see that we can specify a start position. So the first thing it wants to know is the string or the text you're looking for. And in this situation, it's our hyphen. So open double quotes, hyphen, close double quotes, and now type a comma. The second thing it wants to know is where we're searching for this hyphen, and we're looking for it in our customer PO. And type a comma. The last argument has square brackets, and that means it's optional, which means in certain circumstances we don't have to supply it. If we were quite happy for Excel to find the first hyphen, we could leave it off. But we don't want the first hyphen, we want the second. So we need to specify that it starts from position 4 or somewhere after the first hyphen. So that's our find, and if I press enter, it's told me it found the second hyphen at position 10. That's great. The problem is I don't actually want to extract 10 characters. I only want to extract 6. I need to account for the fact that there are 3 characters before Sydney and the hyphen after. That's all being included in that calculation. So I need to subtract 4 to get back to my actual location length, which is 6. So coming back into P2, I'm going to double click and I'm going to type -4 outside the brackets and press enter. And there's my 6. Now that I've done that, I could go and retype it into my mid, but I don't need to. I can just copy paste. So I'm going to select everything from find to the end of the -4, but don't include the equals, and Control C to copy. Now press escape so you don't accidentally mess up your formula, and double click back into O2. Where we had our 1 previously, we're going to remove that, and we're going to paste in our find. Control V to paste. And now press enter. There's Sydney, and if I double click to copy down, there's all my Melbournes. So that was how we could use the find. But the find does kind of rely on us having some form of delimiter, and we don't always have that luxury. What about if there were no hyphens in this example? Well, actually, there is another pattern as well. The location is always preceded by 3 characters and has 7 after. So, in other words, the total length of the string is always going to be 10 plus my location. If I get the total length of the string and subtract 10, that will tell me how long my location name is. And there's a function that can help us with this. It's called the len function, which is an abbreviation of length. Let's see how it works. So clicking back into P2, I'm going to type equals len and tab to open my brackets. And then I'm going to click on my purchase order number and press enter. And as we would expect, the total length is 16. Now we need to subtract the 10 characters that are not our location. So I'm just going to type -10, and we're back to our 6. Brilliant. Let's finish that off by putting our mid function in. So just after the equals, I'm going to type MID and tab. The text I'm trying to chop up is G2. I need to start at position 4 and a comma, and that's how many characters I need to extract. But now we have more than one set of brackets. We must remember to close our bracket for our mid. Tip to the wise, make sure your last bracket is black. When I press enter, there's Sydney, and if I copy down, they're all my locations. So 2 great solutions to this problem, one using find, one using len. The important takeaway, though, is to see how we can actually combine Excel functions to get even more power and solve those more complicated problems. In this video, we're going to look at some Excel functions that will help us clean up text data and even convert the case. The column we're going to be focusing on is the column E, which has the invoice or credit information. You'll notice there are some strange characters in there, that we've got what looks like extra spaces, and the case is a bit of a mix. Zara needs to tidy this all up. The first thing she wants to do is get rid of those weird characters. And the function we're going to use is the clean function. Excel's clean function is quite specific. It is designed to remove the first 32 non-printing characters in the ASCII table. These characters typically come through as spaces, and we get them in our data when we import or download data from an external system. They can cause problems, so it is really important that we clean them up. Good news is, it's very easy to do. So back in our supplier invoice statement, we're going to clean up the data in column E. We're going to start by using the type column. So where we've got P2, can you type equals, and CL for clean, and tab. The clean only needs one argument, and that's the text that we want to clean up. So I'm going to click on E2 and press enter. When I double-click to copy down, all those strange non-printing characters have been removed. You will notice, though, that there are still what looks like extra spaces. So the space is ASCII character 32, that is not removed by the clean function. If we want to get rid of a space, we need to use Excel's trim function. Now, trim doesn't remove all spaces, it only removes extra spaces. And what we mean by that is leading spaces, they come before the text, trailing spaces, which come at the end of the text, and where you have more than one space between the text. So first name space surname, the space will not be removed. But if there were two spaces, the second one would. Let's see how we apply the trim function. So what we're going to do now is trim our cleaned data. So double click into P2, come before the equals and the C, and type TRI, and tab to select trim. Now we have two functions, two sets of brackets. We must put our last bracket in. When we click enter, and again copy down, all those extra spaces have been removed. People often type in extra spaces as well, so that's a really useful function to make sure that there aren't extra spaces. One last thing we need to do now is get all the case looking consistent. We don't want this mixture of upper and lower. And there are three functions that will allow us to change the case in Excel. They are upper, which converts everything to uppercase, lower, which converts everything to lowercase, and proper, which converts the first letter of each word to uppercase and everything else to lowercase. So that's ideal for names and addresses. For this data, we'd like it all to be uppercase. So we're going to come into P2 and double click. And we want to take this whole thing, the result from our trim, and make it upper. So we're going to wrap it in an upper function. So just between the equals and the T, we're going to type U, P, and tab. Don't forget to close your last bracket again and press enter. The first one was already uppercase, but when I double click to copy down, all my data is now uppercase, and that's looking fantastic. So quite a few functions we've looked at here. We've looked at clean for getting rid of the first 32 non-printing characters, trim, which gets rid of extra spaces, and then our three functions for changing case, which were upper, lower, and proper. In the next video, we're going to have a look at some Excel functions that will help us get rid of characters that trim and clean can't help us with. So keep watching. In this video, we're going to look at how we can replace or remove unwanted characters using Excel's substitute function. In the last video, we saw how we could use clean and trim to get rid of certain non-printing characters and extra spaces, but this is quite limited. If you have a look at our paid amount column, we've ended up with an S instead of a dollar, and we actually need to either get rid of that or replace it with a dollar. Trim and clean can't help us with this, but the substitute function can. What substitute does is, given a string, it will look for a string within that string and replace it with anything else you choose. So what we're going to do now is get rid of that S using substitute. We're going to click into Q2, which is going to be our new amount field, and we're going to type equals SUB and tab for substitute. The first argument is the main text string where you wish to make the substitution, and that's going to be our amount. Then we type a comma. The old text is the text we want to replace. So that's going to be our S, and we want to replace that with absolutely nothing. And this is curious. We specify this by opening our quotes and immediately closing them. When we then close our brackets and press enter, that S has been replaced. Perfect. Or not quite. We still have this, what looks like a space, just before the number. Well, if it was a space, we would be able to do this. Substitute S space with nothing. But when I press enter, our S is back, and that tells me that this can't be a space. I would probably also try a clean function on this, but I happen to know that's not going to work either. So I'm just going to remove that space, so at least we've got rid of our S. So now we need to work out how we get rid of this character where we're not sure what it is. Well, again, we're going to do a substitute. And what we're going to do is tell Excel to substitute whatever that happens to be with nothing. But because we're doing another substitution, we're going to need a second substitute function. So coming back to Q2, we're going to double click. And just between our equals and our substitute, we're going to type SU and tab to add another substitute. The string that we're going to make the substitution in this time is our newly substituted string. So we're just going to type a comma after our red bracket. But now we have to tell it what the old text is, and we're not actually sure what it is. We know it's not a space, but what we do know is it's the second character in F2. And to get that second character in F2, we're going to use our mid function again. So let's type MID and tab. The text we're trying to extract something from is our paid amount. And we're going to start at the second position and get one character. Close our brackets for our mid and type another comma. Once we find that character, we're going to replace it with absolutely nothing. Close your bracket for your second substitute. When we press enter, we have now removed both characters from the start, and we can double click to copy down. So the substitute function will allow you to replace a part of your text. If you need to make more than one replacement, you're going to need more than one substitute function. Two other great functions for cleaning we're not going to cover in this video, but check them out in the toolbox. They're Unicode and Unichar. We've covered a lot of great text functions this week, but practice makes permanent, so don't forget to try out this week's practice challenge.
So another action-packed week. Here are the topics we'll be covering: converting data types, understanding dates and basic date functions, generating valid dates, calculating days between two dates, calculating dates from a given date. Each one has a great training video. Don't forget to download the new workbook for this week, as it's a little bit different to last week. And check out this week's toolbox, which has another quick reference guide and some really useful bonus material, which will help you with this week's practice challenge. Everyone say, wow. In this video, we are going to learn about two Excel functions that can help us convert data in Excel. Last week, we helped Zara sort out the amount field so they are all showing as valid numbers. What Zara needs to do now is add those all up so she can compare the total to the other report. So click in V1, we're going to type equals sum and open our brackets. I'm going to click on Q2 and Control-Shift down arrow to select them all. And then I'm going to just press Tab, so I jump back up to the top row. Small problem, we've got the answer 0. Now, why is that happening? Well, the first clue is, if you have a look at these numbers, they're all aligning to the left. And that is often a hint that there is a problem. Numbers in Excel automatically align to the right. What's happened here is, although it contains valid numbers, we got to them by using text functions. This data is being stored as text, and this can be quite a common problem with data that comes out of external systems. Before we can perform any arithmetic operations on these values, we need to actually convert them to proper numbers. And the function that will help us do this is the value function. Now let's have a look at how it works. I'm going to just click into V2 and type equals VA and tab to select value. And when I click on the amount and press enter, you'll see it's actually aligning to the right. It's behaving like a number. All right, I'm going to undo that, and we're now going to apply the value function to our existing calculation. I'm going to double click into Q2, and there's already a fairly large calculation there. We want to take the result of that whole calculation and apply a value. So we're going to click between the equals and the substitute, type VA, press tab. Don't forget to close your brackets at the end, press enter, and hey presto, you've got a number. And when I double click to copy that down, all of our data has converted. So that's the problem sorted with getting text to numbers. Now I should just point out that if you tried to apply a value function to a cell that contained a non-numeric character, you would actually get a value error. So you will need to make sure you've only got numeric characters inside that cell. What we're going to look at next is solving the opposite problem. That's where you have a number or a date and you want to convert it to text, and that's the problem Zara has encountered in the other report. So let's just click into the next tab, and just like she did in the previous sheet, she needs to get the invoice month. And if you have a look at the data here, it's been stored as a proper date. And so we can't use our left, right, or mid functions that we learned about last week to extract it. The function we're going to need here is the text function. The text function is almost like the opposite of the value function. It takes a valid date or a valid number and converts it to text. Let's have a look at how it works. So clicking in K5, I'm going to type equals TE and tab to select text. The first thing it wants is the value we want to convert. So I'm going to click on my invoice date and type a comma. The next thing it needs to know is what do we actually want to get back? Do we want month? Do we want year? Well, we tell Excel this by giving it a kind of code. I'm going to start by opening my double quotes because it's going to be a text code, and we use D to represent days, M for months, and Y for years. Now a single D will return me a day without a leading zero. So this case would give me a 2, but for this case it will give me a 16. If I put 2 Ds, that would give me a 0, 2, or over here, 16. 3 Ds will actually give me the day of the week with just the first 3 characters, and 4 days will give me the whole day of the week. So let's just have a look at how that works. I'm going to press enter, and you can see that was a Monday. Well, that's not actually what we want. We want the month, and for the month, we're going to use M. So I'm going to type 3 M's, which will give me the month abbreviated to 3 characters. And when I press enter, there we go. And we'll copy that down. So the 2 functions we've seen are the value function, which will take numeric characters stored as text and convert them to numbers, and the text function, which will take numbers or dates and convert them to a text format of your choosing. So 2 very useful functions for converting your data into the form you need. In this video, we're going to take some time to understand how dates work in Excel and to get to know a few of the more common date functions. The first thing we need to understand about dates in Excel is that they are just in fact numbers formatted to look like dates. Let's have a look at an example. I'm going to click into D2 and I'm going to type the number 1 and press enter. And well, I get the number 1. But what I would like you to notice is in the number formatting section, the format is set to general. That basically means no format has been applied. If I click the drop down and change that to short date, it changes to the 1st of January 1900. Interesting. If I now type the number 2, now remembering that this is now formatted to be a date, and press enter, I get the 2nd of January 1900. So you get the idea. Dates are just the number of days since the 1st of January 1900. This has 2 very large implications. The first is we now understand why our dates sometimes come up as numbers and our numbers sometimes come up as dates, and to fix the problem is very easy. All we need to do is come back to our number format and switch it back to the format you actually want. More importantly, however, it means we can perform arithmetic operations with dates, and this is where it gets much more interesting. So I'm just going to delete these, and we're going to click into B2. Now, very often, before we can perform any calculations with dates, we need to know what the current date is. So if I were to work out how old somebody was, or how overdue an invoice was, I have to have a reference point. But obviously that reference point is going to change tomorrow. So I need some way of Excel automatically working out what the date is. And there are 2 functions that can help us with this. I'm going to ask you please click on the formulas toolbar. And the first group is our function library. Now this is great because it has a list of all the Excel functions. So if you have forgotten what they're called or you want to see what else is available, you can always come back here and have a look. If we have a look at the text functions, for example, you can see all the text functions we worked with last week, as well as a few additional ones you might want to investigate. This week we're looking at date functions. I'm going to come to date and time, and again you'll see quite a rich selection available for us. Now the 2 functions that will help us work out today's date are the now function. If I hover over, there you'll see it returns the current date and time formatted as date and time. So that will give us the date and time. If you just want the date, then you're better off using the today function. And that's the one we're going to click on. So let's click on today. And a little message box appears telling us that this is volatile. There are a few Excel functions that are volatile. All it means is that when there is a change in the workbook, this function will recalculate. If you have millions of this function, that could cause performance overhead. But as we never need more than 1 day function in a workbook, it's not a problem at all. So you can just press enter or click OK, and there's today's date. Obviously, if you're working alongside me, you won't have got the exact same date as mine. You would have got whatever the date is where you are right now. So just to recap, the now function returns the date and time. The today function returns today's date. And when I open up this workbook tomorrow, it will actually have tomorrow's date. Last week, we also had a look at functions for separating text. However, we can't use those same functions for separating out our dates. So if I want to just extract the day or just the year, the left and the right functions are not going to help me because actually this is just a number. Excel provided us with 3 date functions specifically for separating our dates. And if we come back to our date and time functions, we'll see we have day, month, and year, and these basically perform a similar function to the left, right, and mid functions. But they extract the day, the month, or the year as a number. Let's see how these work. So I'm going to come into L5, and I'm going to type equals DAY and tab. Now the argument it needs is a date. It says serial number, which is a little confusing, but we now know that dates are in fact numbers. So we're going to click on invoice date and press enter, and you can see what's returned, the second. And if I double click, copy that down, I can now see the day on which I was invoiced. Now very similar, and I'll just do them in their cells to the right to demonstrate, you have your month function. This will return the month number. So I'm expecting a 3 here. I'm just going to press tab, and you can see that as my month number and the year work very much the same way. So equals year, click on my invoice date, press enter, and there's my 2020. So 3 functions which allow us to separate out dates: day, month, and year. In the next video, we're going to look at how we perform the reverse of this operation, and given a day, month, and a year, create a valid date. In this video, we're going to look at how we can generate valid dates using Excel's date function. And for this example, we're going to be working in our supply invoice statement. So I'm just going to click back into that. And you may recall that in the supply statement, the paid dates and the invoice dates are not actually valid dates. They are just text. And now we need to help Zara convert those to valid dates so that we can do comparisons and operations with that data. Now the function we're going to use is the date function. And we're going to start with a really simple example so you can see how it works. So clicking into S2, we're going to type equals D, A, and tab to select date. The date function requires 3 arguments: the year, the month, and the day. And each of these has to be a number rather than text. Well, our year is 2020 and a comma. All of the invoices were paid on the 4th and a comma. And this particular invoice was paid on the 17th. So I type 17, and now notice no quotes because these are just numbers. And then I press enter, and there's my valid date. So that's how the date function works. But obviously we can't type in the 17th because the pay dates were different. So we need another function to extract that for us. Yep, you guessed it, it's the right function. So coming back to our calculation, we're just going to double click into S2, and then I'm going to remove that 17 because we're going to replace it with a calculation. And like I said, the calculation we need is using the write function. So I type R, I, and tab to select write. The text we're using is the paid date, then a comma, and we need the 2 characters on the right. Don't forget to close your brackets, press enter, and now we have a valid date. But if we copy it down, we can generate the paid dates for all of our invoices. That was quite a simple example because our year and our month were the same in every case. The next example we're going to look at is the invoice date. Now the year still stays at 2020, but the invoice months actually vary. So we need to have a way of somehow converting MAR to a 3 and APR to a 4. And actually we already know the answer. Interestingly, the month function will retrieve the numeric month for us from anything that looks like a date, even if it's not actually a valid date. So this is a nice little surprise. I'm going to click into R2, and I'm just going to have a look at how the month function works with this data. So I'm going to type equals MON and tab. We're going to click onto our invoice date and click enter, and it actually returns the 3, which is fantastic. Often, however, we don't actually have the luxury of something that looks like a date. It is more common to just have the month name, and if I tried that with the month function, you'll see that doesn't work because that doesn't look anything like a date. That's just really text. But there's a clever little trick you can do to get around that. So coming back into here, what I'm going to do is I'm actually going to join a 1 onto the front. So I'm going to type 1 and then I'll ampersand, which is our concatenate operator. So basically I'm saying the 1st of March, I'm only worrying about a space, and curiously, that also works. So that's a really useful trick if you happen to have just the month name on a column in its own. You can convert it to a number using the month function by just joining it to a 1. Okay, let's just finish this off. So I'm going to double click back in right at the beginning. We're going to put our date function, and our year is still 2020. So I'm going to type that followed by a comma. We've then got our month function, which is going to calculate our month number for us. So another comma. And then once again, we're going to need a write function. So I'm just going to type RI tab for write. The text I'm trying to work with is the invoice date. Again, I need the 2 characters on the right. Close my brackets from write. Close my brackets for my date. And there's our valid invoice date. And again, we can just copy that down. So we've seen that we can use the date function to generate valid dates, provided we give it a year, a month, and a day. In the next video, we're going to start looking at how we can do mathematical operations with our date functions. In this video, we're going to look at how we can perform calculations with dates and some of the functions that can help us. The first thing Zara needs to do is work out when the invoices are actually due. Now, for argument's sake, let's say they were due 6 days after the invoice date. All she'd need to do is click in E5, type equals, click on the invoice date, and add 6. Because dates are really just numbers, you can work with them like numbers, and there's our due date. Let's double click to copy that down, and you can do subtractions with dates in exactly the same way. So I'm going to click into M5 and going to work out how much our invoice is overdue by. So I'm going to type equals, going to take our payment date and subtract our due date. And there you go. There's a function we can use to subtract days as well. It's called the days function. If I click into M5 and type equals day and make sure I choose days, plural, I specify my end date first. So that's going to be my payment date and then my due date. And you can see I get exactly the same answer. And I'll double click to copy that down. Now coming back to our due date, let's just check something, and that is what day those payments are falling on. So I'm going to click on F and press Ctrl+Shift+ to insert another column. You can also use your insert tool. And just a reminder, we can use our text function. I'm going to click due date, and remember we need to type quotes, DDD, close your quotes, and enter to get the day of the week, and you'll see we have a problem. A lot of these due dates are falling on Saturdays and Sundays, which in Australia are non-working days. And very often for these types of calculations, you need to take working days into account. And there's a function that can help us. It's called the workday function. Let's now change our example to say that the due date is actually 6 working days after the invoice date. So clicking back into E5, I'm going to type equals WORK and choose workday. My start date is still my invoice date, but this time I want to add 6 working days, so it's actually going to skip the weekends when I press enter. You see that has worked beautifully. No Saturdays or Sundays showing. Now obviously for different countries and different organizations, Saturday and Sunday are not always the non-working days. So Excel offers us another function similar to the Workday, but called Workday International. And this will allow you to actually specify what your work week actually looks like. So typing Workday International, I'm going to click my invoice date and a comma. My day is still 6, but next, for argument's sake, let's say we don't work on Sundays or Tuesdays. You'll see options down here that may fit your business, but if it doesn't, there's another option. You can actually give it a code, and the code looks like this. Open your double quotes, and then you need to type 7 zeros or ones. 1 representing a non-working day, and 0 representing a work day. Excel starts with Monday, so in our example, Monday is a working day, so we put 0. Tuesday, non-working day, so 1. Wednesday, Thursday, Friday, Saturday, zeros, and 1 for Sunday. Close your double quotes and enter. You'll see our due date has moved to 1 after the Tuesday because Tuesday is a non-working day. So I'll just copy that down. Wait, there's still one problem. I happen to know that in Australia, the 10th of April is Easter Friday, and that's actually a public holiday. The great news is that the Workday and the Workday International functions will allow us to take holidays into account. I'm just going to come to E6 for a moment and change just this one. When I double click, you'll see at the end, it allows me to specify holidays, but what I can't do is just type the date as I normally would. Because remember, dates are actually numbers, so one way of solving this problem is to use a date function. So I'm going to put in date. The year is 2020. The month is April. and Easter Friday falls on the 10th. Close my brackets, and that has taken the holiday into account. The problem is Saturday, Sunday, and Easter Monday are also holidays. And to have to start typing them all in is really going to be a pain. So a better way of dealing with holidays is to actually have them listed somewhere else in your workbook. And then just select them. And that's what we're going to do. So we're going to come to E5, double click, and right at the end of my double quotes, but before my brackets, I'm going to type a comma. And I've got the holidays in the New South Wales holiday sheet. And I'm just going to select all those dates. So I can copy the formula down and then just press enter. It hasn't affected this first date, but when I double click to copy down, you'll see this is actually being pushed out to the next working day. That's not a holiday, which is Wednesday. Really clever. Now, on the other side of the coin, if we need to subtract working days, we have our network days function. So let's come back to our overdue by. And let's work out how many days it's overdue by. I'm going to type equals NET. And you'll see again there's a network days or a network days international. And they work pretty much like the work days. We'll just use network days for simplicity. Our start date now, and this time notice we're putting a start date first. That's going to be our due date. Our end date is going to be our payment date. And our holidays, begin to specify that again. And you can see it has adjusted to only show us how many working days, not including holidays, it is overdue by. So quite a few functions we've looked at here. The days function for subtracting two dates, then work days and work days international for adding a certain number of work days, and network days and network days international for subtracting a certain number of days. This business case only really required us to work with days. But if you need to work with years, for example, there's a fantastic function called yearfrac. And we've included this in the toolbox, which I'd encourage you to check out. In this video, we're going to continue looking at doing calculations with dates, but we're going to introduce two really exciting date functions: the end of month and the end date. So coming back to our example in the last video, we looked at how we could calculate the due date by just adding 6 working days. In reality, life is not always that simple. Very often, invoice due dates are calculated from the start of the next month or exactly a month after. So let's say that what someone actually needs is to calculate the due date 5 working days into the next month. The function that can help us with this is the end of month function. It will be at the end of the month after a certain number of months for any given date. Let's have a look. So clicking into E5, we just type equals EO and select EO month. Now we have to give it a start date, and that's going to be our invoice date, and then a comma. Now we can specify a certain number of months before. So for example, if I type -1, that will give me the last date in February. If I add 1, that will give me the last date in April. But I actually want the last date of the end of this month. So I'm just going to put a 0. And you can see it gives me the 31st of March. Now I've got the end of the month. All I need to do is add my 5 working days on. And we already know the function to do that, and that's our workday function. I'll just go back after the equal sign, type in workday. So that's our start, and we're going to add 5 to that. When I press enter and copy down, you can see in every case, it's given me the first working day, 5 days into the next month. And that's our EO month function. Now the other one that's really handy is the eDate function. What this allows us to do is add a number of months or subtract a number of months from a given date. Let's have a look at it very simply. So in this situation, our invoices are going to be due exactly a month after the invoice date. I'm going to click into E5 and type equals eDate. And again, we must give it our start date, which is our invoice date, and a comma. And now again, we can add or subtract a certain number of months. And I want to add exactly 1 month. That gives me exactly a month after my invoice date. When I copy it down, however, we're back to our problem of having Saturdays and Sundays. So we still need to convert this to the next available work date. There's, however, one small restriction with the workday function, and I'm going to demonstrate. We only want to add a day if it's a non-work day. So really we want to add 0 days in this case. The problem is, if you put 0 as your value, it does not affect any of the dates. So we have to add or subtract at least 1 when working with the workday function. How do we get around this? Well, simple. We've got to put 1 on here. So what we're going to do is we're going to subtract 1 from here first. What that will do is subtract 1 from the eDate calculation and then add 1. And if that's not a work day, add any others it needs to make it a working day. Let's see that work. So you'll see this didn't change. It is still the 2nd of the 4th. When I copy down, all the non-working days have now been converted to work days. So there's a little bonus trick on working with the workday function. So 2 functions we've looked at in this video. They are the end of month and the end date. This week we've looked at a really great selection of functions for working with our dates. To help get proficient in these, I'd encourage you to try out this week's practice challenge. So our 5 topics this week are cell referencing and naming, creating named ranges, managing named ranges, calculations with named ranges, and then automating processes with named ranges. Don't forget to download this week's exercise files and work alongside. Take some time to check out the toolbox and cement those skills with this week's really interesting practice challenge. And now it's over to you.
In this video, we're going to revise conventional cell referencing in Excel and introduce an exciting alternative called named ranges. Now that our data is all transformed and cleaned, we're ready to start performing calculations. And the first thing Zara would like to do is work out the late charge for each of the overdue invoices. Late charge is calculated by taking 0.36% of the invoice amount and multiplying it by the days overdue. So let's see how we do this. I'm going to click into N5 and type equals. We'll grab our amount, multiply that by our overdue by, and then times that by our penalty rate. When we press enter, there's our late charge. But when I come to copy it down, we have a problem. Now the reason for this is when we create an Excel calculation and copy it down, the cells it's referring to move down as well. This is called relative referencing, and it's the reason we can normally copy our formulas. But in the case of the N2, we didn't want that to travel. We wanted that to stay N2. So how do we do this? Well, one option would be to just times the penalty rate in there. This is not a good option though. We really want to always retain a single point of entry. So in other words, if we needed to change our rate, we would only change it in one place rather than in loads of calculations. The other thing is we want our sheets to be self-documenting. So it's good that we can actually see the rate there without having to go into our calculations and see what rate is being used. So really it's good practice to refer to the rate. What we need to do is just tell Excel that that needs to stay fixed, or what Excel calls absolute. And we do this by putting $1 in front of the column and $1 in front of the row for the cell that we want to stay locked. Now typing the dollars will be very tedious, so instead we're going to press F4 on our keyboards. On some computers you may need to press function F4. You'll see that's put our dollars for us, and what that's saying is whether we drag the formula down or across, N2 will stay fixed. If I press F4 again, you'll see I've only locked the row. So this will fix it if I drag down, but not if I drag across. And of course I can press F4 again and just lock the column. If I press F4 one more time, I'm back to my relative. So 4 options: relative, absolute, and 2 mixed cell references. The one we want in this case is the absolute, so I'm going to press Enter, click back on my formula, double-click to copy down, problem solved. And this is a good solution that you will see used and you will probably need to use yourself. The only problem is that when our calculations get much more complex and we're pulling data from different sheets, they become very messy and very hard to understand. So we're going to look at a much more elegant solution called a named range. Let's delete those formulas because we're going to redo it in a moment. So I'm just going to press delete and I'm going to come back up to N2. Wouldn't it be nice if rather than calling that cell $N$2, I could call it something sensible like penalty rate? Well, that's exactly what I can do. And I do it by clicking on the cell I want to name and coming up to my name box, which is the small box to the left of your formula bar. You'll see at the moment that cell is called N2, but I'm going to click in there and I'm going to change the name to penalty underscore rate. And when I'm finished typing, I'm going to press Enter. Don't forget that step. If I click away for a moment, to find out what named ranges exist in a workbook, you can come back to the name box and click the drop-down list. They'll all be listed there. I can see my penalty rate. And if I click on it, it actually navigates me to it. So the name box can be used to create name ranges and to locate them. Let's now see that used in our calculation. So back in N5, I'm going to type equals, click on my amount, times by my overdue by, times by, click on my rate, but this time you'll see it uses the named range. And because that name refers to a specific cell, I'm automatically getting an absolute cell reference. So I press Enter, I copy my formula down, it works perfectly. It's easier to understand and I didn't have to worry about the dollars. You probably realized that there were some rules about how we name our ranges, and I'll just quickly run through those. The name can be up to 255 characters long. It must start with a letter or an underscore, so you couldn't have 2019 sales, you'd have to have sales 2019. It can consist of any combination of letters, numbers, and underscores, but no spaces, no hyphens, and most punctuation characters won't be accepted. So just stay with the letters, numbers, and underscores. They have to be unique. usually within the workbook, although we will look at an exception to that later on this week. And slightly more subtly, they can't be a cell reference. Now, of course, you wouldn't want to call your named range N6, but here's a mistake that's quite easy to make. I've selected these values and I'm going to name this range top 10. Looks all right when I press enter. Can you see the problem? Top 10 is in fact a cell reference. Any 1 to 3 letters followed by a number is going to be a cell reference, so solve the problem by putting an underscore. All right, I'm going to press Control Home just to hop back. So just to recap then, to name a cell, we click on the cell we want to name, come to our name box, type in the name, and press enter. In the next video, we're going to look at some other options for creating named ranges. In this video, we're going to explore some of the different options for creating named ranges. Very shortly, Zara's going to start performing calculations using entire columns of data, and to make her life a little easier, she would like to name them. In the previous video, we saw how we could name a single cell. Well, the process is very much the same for naming an entire column. We start by selecting the column. So I'm going to come to my late charge, but note I'm not including the heading because it's not part of the data. To select all the data, we're going to press Control-Shift-Down arrow, and then we're going to come to our name box as we did in the previous video, and I'm going to call this late underscore charge, and press enter. What has happened is we haven't given each cell the name late charge. Instead, we've named the entire column late charge. So that was using our name box again, which is quick and easy, but there are some other alternatives which give us more options. And we'll find these on the Formulas tab of the ribbon. If you have a look in the Defined Names group, these are all of the tools for working with named ranges, and they're quite a few. The next one we're going to look at is called Define Name, and again this allows us to create a named range. So let's do our overdue by data this time. I'm going to click into M5, then press Control-Shift-Down arrow. But this time I'm going to press Define Name. This is the new name dialog, and you'll see it's picked up the label for us automatically. So that saves us a bit of typing. I could adjust the range it's referring to, which is handy, but the main reason for looking at this tool is the scope. In the last video, I said that typically the scope was the whole workbook. In other words, the named range had to be unique within the workbook. But if you wanted to have two named ranges the same in different sheets, you could change the scope and restrict it just to a single sheet. This is not usually desirable, so we're going to leave it as workbook, and we're just going to press OK. If I come back to my name box, you can see that named range has been added. We still have quite a few columns to do though, and this could be time consuming if we did them one by one. So now we're going to look at my favorite tool, which is Create from Selection. This allows us to create multiple named ranges simultaneously using the labels already in the workbook. So how do we do this? We're going to start by clicking into A4 and dragging across to select all of our labels. I know, I specifically told you not to do that, but these are not going to be part of the range. We're just selecting them so it knows what to call each range. Then again, we're going to press Control-Shift-Down arrow to select all our data. If I come up to Create from Selection and hover over it for a moment, you'll see the keyboard shortcut is Control-Shift-F3. And the more you use this tool, the more likely you are to remember that. But for now, we're just going to click on the tool, and I need to explain what it's doing here. It's saying, do you want me to use the labels in the top row to name each column? Yes, we do. Do you want me to use the labels in the left column to name each row? No, we don't. So Excel will take a pretty educated guess based on where it finds text. But if you do have text in your first column, don't forget to untick that. And now we're going to say OK. If I come back to my name box, you'll see each of those named ranges has been added, and if I select amount, for example, it has named the entire column, but not included the heading. So 3 options for naming ranges. The name box is ideal if you quickly need to name a large range or a single cell that doesn't have a label. The define name is good if you need to name a single range and you need that additional scope option. And the create from selection is our fastest option when you need to create multiple named ranges using labels already in the workbook. Don't worry if you've made some mistakes. In the next video, we're going to look at how we can use the name manager to edit and delete named ranges. In this video, we're going to look at how we can manage our named ranges using a tool called the Name Manager. In the last video, we helped Zara name each of her columns, but she's decided that amount paid would be a better name for her amount data. Now, what we don't want to do is go and create another named range called amount paid. It won't replace the first, it will be added as well, and we'll end up with 2 named ranges looking at the same data, which may cause confusion and problems down the line. So what we're going to do is actually edit the existing named range. And we do that by coming to our Formulas tab, and in the Define Names group, clicking on our Name Manager tool. If you hover over it, you'll see the keyboard shortcut is Ctrl F3. I'm going to click on that, and similar to the name box, it gives us a list of all the named ranges, but you can see it gives us a lot more information, like the values contained, the cells it refers to, and the scope. It also gives us the option to create a new named range, edit an existing one, or delete an existing one. Now we want to edit the amount named range, so making sure it's highlighted, we're going to click the Edit button, and then we're just going to click into the name box and type our underscore and paid. You'll notice we can also change the cells it refers to, but we can't change the scope, so that's one thing you have to get right up front. Now click OK, and our named range has been updated. Any calculations that refer to this named range will automatically pick up the change, so this won't impact our calculations in any way. The other thing we can do is create a brand new named range. Now I'd like to create one that refers to my system date cell, so I'm going to click the New button, but you'll see it automatically picks up the values that I had highlighted previously. So I'm going to change the name to be System Date, but then I'm going to change the range it refers to be B2. I can also change the scope, so I'm going to do that so you can see the difference, and I'm going to make it MC Invoice Report, and then I'm going to say OK. Our new named range has been added. Let's go and use that in a formula, and we'll see how the scope affects the named range in our calculation. So we're just going to click Close for a moment. Can I ask you to click into D2 and type tomorrow, and then tab to E2, and we're going to do a little calculation to work out tomorrow's date. So that's going to be equals, click on your system date, plus 1, and then press Enter. Now remember, if our dates don't come up in the correct format, we just come to our Home tab, come to our number formatting, and we're going to make that a short date. So that's looking fine. Now the next thing we're going to look at is what happens if we delete a named range. So coming back to our Formulas tab, I'm going to come to my Name Manager. I'm going to scroll down till I get to System Date, and I'm going to press Delete. Excel is going to check, are you sure you want to do this? And you actually do need to be careful, but for now we're going to say OK and close. You'll see my formula immediately breaks. If you delete a named range that is being used by a calculation, it will not replace the named range with the original cell reference. It will simply give you a name error. So that's something to be very cautious of. Now in this case, we don't actually need that calculation, so I'm just going to remove it, but do be cautious when deleting named ranges. Now one last little thing we're going to look at in this video. While we know to go and look at named ranges in the name box or the name manager, other people might not know about these tools, and so it's handy to know how we can document our named ranges in the workbook. And Excel provides us with a tool to do this as well. So just so we don't get in the way of anything, I'm going to click into Q5. I'm coming back to our define names. We're going to come to the use in formula and click the drop-down arrow. And right at the bottom, there's a paste names option, which we're going to select. And then we're going to choose paste list. And if I just double click between the Q and the R to widen that a bit, there's our full list of named ranges as they currently stand. This will not automatically update, so it's just a snapshot, but it's very handy to quickly document your named ranges. So two things we've looked at there, the paste names and the name manager, which will allow you to edit, delete, and even add new named ranges. In the next video, we're going to start using our named ranges in our calculations, and then we'll start to see why they are so useful. In this video, we're going to look at performing calculations with named ranges. And to help us, we're also going to introduce two great functions called countifs and sumifs. Zara's first calculation is she needs to update the late charge. It turns out, as well as the penalty rate, there's a $2 a day flat rate for overdue invoices. She's also been asked not to put the flat rate anywhere in the worksheet. The problem is we still want to keep that single point of entry. Well, we can use a named range to solve this. So we're going to come back to our name manager on our formulas tab, and we're going to click the new button to add a new range. And we're going to call it flat_rate. We do not, however, wish it to refer to a particular cell in the sheet. So I'm going to remove all of this, and instead I'm going to just put the number 2. This is called a constant because unlike a cell which can vary, this is always going to be 2. And then we say OK. You'll see our flat rate has been added, and we can say close. Let's go and change our calculation now. So I'm going to double click into N5, and then after penalty rate, I'm going to type plus, and then take my overdue by and multiply by my flat rate. But I can't click on it. Here's what makes named ranges really great. If I type FL for flat rate, it actually comes up in my autocomplete, and I can just press Tab to finish that off and press Enter. My flat rate has been added, and I can double click to copy that down. So that was a slightly unusual use of named ranges, but it can be very useful for conversion rates or values you just don't want people to see, but you want to include them in your calculations. Let's look at a more typical use of named ranges in calculations. We're going to now come to our recon analysis sheet, and this is where Zara actually needs to start comparing the values in the two sheets. And the first thing she needs is a bottom line. What does the supplier say we paid? What does our system say we paid? So we're going to need to add up the amounts in each sheet. But we haven't actually put a named range in the supplier statement. So the first one we're going to do, you'll see how it looks without a named range. So clicking in B3, we're going to type equals and sum. Then tab to just open your bracket. But now I have to go and select the data from a different sheet. So I'm going to click onto the supplier invoice statement. I'm going to come to the top of my amount column, click on Q2, and you could drag down, but it's much quicker to press Ctrl-Shift down arrow. And then really important, do not click back into your recon analysis, press Enter. That has worked, but it's quite a simple calculation, and it was fairly fiddly to create, and you can see the resulting formula is quite long and quite ugly. Let's see a very similar calculation, but this time using a named range. So in B4, we're going to type equals sum and tab to open our brackets. But now we don't have to click into that sheet. We can just type the named range. So AM, down arrow twice, and tab. Didn't even have to use my mouse. Lovely formula as a result. Press enter. Job done. Now, as our calculations get more complex, and the more we're pulling data from different sheets, and particularly when we then start adding dollars on as well, our named ranges make our calculations much more elegant and much quicker. Let's look at another example. So the next thing I want to do, and I'll just click back into my invoice report for a moment, is we want to find out how many invoices were generated from Sydney and how many from Melbourne. So really what I want to do is count how many times the word Sydney appears in my location column. And the function that will help me with this is my count ifs. So coming back to my recon analysis, make sure B8 is selected and we're going to type equals COU. And there are quite a lot of count functions. You'll notice there's a count if singular and a count ifs plural. Count if singular only allows for a single criteria, whereas count ifs plural is the newer one, 127 criteria. So let's use that one. I'm going to double click. The first thing the count ifs wants to know is which column am I checking? And in this case, it's the location. So I'm going to just type LOC because I've named it, and tab. Then a comma, and it says, fine, I'm going to look in the location column. What am I looking for? We're looking for the word Sydney. And then press enter. And when I copy that down, there's my total invoices for Melbourne. Similar to the count ifs, there's also a function called sum ifs. And that's what we're going to need for our next example, where we actually want to add up the amounts for Sydney and Melbourne. So it's similar, but when it finds the word Sydney, it's actually going to add up the corresponding amount in the amount column. Back in our recon analysis, we're going to click into C8 and we're going to type equals SUM and choose sum ifs and tab. Now the sum ifs requires an additional argument because it needs to know the column you're going to add. And this is our amount paid. So I'm just going to AM, down arrow twice, and tab. Then type a comma. Now it's very similar to the count ifs. I need my criteria range, which is my location, and I need my criteria, which is Sydney. Press enter, double click to copy down. So what we've seen there is that by using named ranges in our calculations, we actually make them easier to create and the resulting function itself much easier to understand. We also introduced two functions for aggregating data, the count ifs and the sum ifs. Take a moment to check out the toolbox, which also introduces you to the average ifs, max ifs, and min ifs. In this video, we're going to start looking at how named ranges can be used to automate functionality in workbooks, and this is actually the most important reason for using them. The example we're going to look at is how we can automate data validation, but that's just one of many examples. Now, just before we get started, we're going to create one last named range, so good practice. We want to name the locations named range, and the quickest way to do this is using our create from selection. So I'm going to select from A7 down to A9, and keyboard shortcut, you may remember, is Control-Shift-F3. Top row is what I want, so I'm just going to press enter. And if I double check my name box, there's my locations, and it's my two cities. Right, let's come back into our invoice report. Zara has added conditional formatting so that if I come into K2 and type Sydney, it automatically highlights all the Sydney rows. And of course, the same happens for Melbourne. Now, we're going to look at conditional formatting a lot more in the next course. But what we're going to focus on is Zara's problem, which is she doesn't want to have to type it in. She would like a drop-down list where she can select Sydney or Melbourne. Now, to do this, we use something called data validation. Just going to delete that for a moment. With K2 selected, we're going to come to our Data tab and we're going to click Data Validation. Data validation allows us to control what users input into a cell, so we can specify that a number must be within a certain range, for example. It also allows us to create drop-down lists. And to do this, we change the any value to list. In the source box, we need to specify what we see in that list, and we could just type values, but then we would have to come and manually change it every time there was a change. And that we don't want. So we're going to use a named range instead. You can type the name of the range, or even better, you can come to your Formulas tab, click Use in Formula, and choose Locations. The keyboard shortcut for this is F3. Now we're going to click OK. A drop-down has appeared, and if I click on that drop-down, I can choose Sydney or Melbourne. So that's half of it done. We've created our data validation and we've linked it to a named range. But we would like that named range to automatically grow. So back in my recon analysis, if I add another region, I want it to appear in my drop-down list. So I have to have a way of somehow making my named ranges more dynamic. And we can do this using a calculation. The calculation has two parts. The first part is to work out how many values we actually have, and that's quite straightforward. I'll demonstrate in this cell over here. So if I type equals COU, I want to count, but I'm not counting numbers, so I have to actually use the count A function, which is count alphanumerics. So I'm going to double-click count A, and then assuming I'll never have more than 10 regions, I'm going to select A8 down to A18 and press Enter, and that's telling me there are 2. If I added another region, you can see it picks up 3. I'll undo that for now. So that's the first part, but the named range actually needs the actual values. And to do that, we're going to need to use a slightly trickier function called the offset function. What the offset does is, given a starting point, it will return a block of data a certain number of rows or columns away from that starting point. Let's go build the whole thing in the Name Manager. So back into my Name Manager, I'm going to come to Locations and I'm going to click Edit. And I'm going to replace this hard-coded named range with something that is calculated. I'm going to remove all of that and I'm going to use the offset function to do this. So I'm going to type offset and open my brackets. Now it has to have a starting point, and that is our first location. So I'm going to click on A8 and then type a comma. Then it wants to know how many rows away from that starting point we want to begin, and that's 0 because we're starting there. Then a comma. Next it wants to know how many columns away we want to start, and again that is 0. And then another comma, and here is where we specify how many rows we want to include in our range, and we do this with our count A. So again, count A and select A8 down to A18. Close our brackets for our count A, close our brackets for our offset. And now you can press OK and close. Let's go check that our named range is still working. So we're going to click the drop down, and you can see it's still Sydney and Melbourne. But if I now come back into my recon analysis and add Perth, when I check my drop down this time, Perth has been added. So what we've seen is how our data validation has automatically updated by using something called a dynamic named range. And for a long time, this was the only way we could do this. But that calculation is a little bit tricky, so I have some great news for you. Next week, we're going to look at a feature called Tables, which adds all this automation for us without actually having to create that scary offset function. For this week, though, you've done really well. Don't forget to check out our practice challenge, which will help you consolidate all your skills.
We have 5 great videos for you this week that will cover the following topics: creating, naming, and removing tables, formatting and selecting in tables, sorting and filtering tables, performing calculations with structured references, and then automating processes with tables. Don't forget to download this week's workbooks so you can practice the skills as you go. We've got the usual quizzes for you to test your skills and another great practice challenge. Have fun with it, and now it's over to you. In this video, we get to look at how we can create and name tables in Excel from the discussion video. We talked about how tables were a really powerful automation tool. So what do we mean by that? Well, we've just spent quite a lot of time helping Zara to create a lot of calculations and name ranges to make it easier to work with this data. But imagine that somebody with maybe a little less skill had to add a new record at the bottom of the data. They would need to make sure they'd copied those formulas down correctly, added the data validation, added the conditional formatting, and updated all the named ranges. That's a big ask. It's going to take a while, and most importantly, they may not have the skill to do it correctly. So automating this process becomes very important to businesses. And it does become very easy. All they have to do is use a table. Now, not all data lends itself to be converted to a table. We're looking for databases of data like this, organized into columns where they store one type of information and where each row represents a record about one person or one thing. No blank rows, no blank columns, but blank cells are fine. And ideally, the data is not touching anything else. If that's the case, creating a table is very easy. We just click somewhere in the data, we come up to our Insert tab, and we click Table. It double checks that this is the range you have intended. And if you followed all the guidelines that we stipulated, that will be correct. If it isn't correct, you can always go and select the right range. And my table does have headers, so I'm just going to say OK. Now, quite a few things have happened. We've got some great formatting, auto-filter buttons being added to the top of each column, and perhaps more subtle, a brand new ribbon tab has appeared called Table Design, or in other versions of Excel, Table Tools Design. Now, if I click outside of the table, you'll see I don't have that ribbon tab. And when I click back in, it reappears. So please make sure when you are working in the table that you've clicked inside it. Now, coming up to the Table Design ribbon on the left-hand side, you can see the table has automatically been given a name. Table 1's not a great name. So one of the first things I'd suggest is you replace this. And I'm going to call this TBL_supply. The same rules apply for table names as for named ranges. The TBL is not required at all, but it actually makes it much easier to distinguish our tables from our named ranges, and to find them quickly in the autocomplete. So it's just a recommendation. Once you finish typing, you can just click away or press enter, and there's your table appropriately named. Let's have a look at that again. So I'm going to come to the MC invoice report. And we're going to turn this into a table as well. Click somewhere in the data, come to table, but this time I'm going to hover for a moment, and you'll see the keyboard shortcut is Control T. Next time we'll use that one. I'm going to click Table, and then I can just press Enter, and my table has been added. Now, what if I needed to remove this table for some reason? Let's just say we don't want it anymore. Well, that's easy to do. But before you do, you need to decide if you want to keep the formatting. Because when you remove the table, the formatting will not automatically be removed. So to remove the formatting, we come to our table styles and just choose Light, which has put it back to how it was before we added the table. And then to remove the table, we click Convert to Range. It double checks. It's fine. Removing the table will not impact the workbook or formulas in any way. So we can just press Enter, and now we're back to what's called a regular range. We do, however, actually want the table, so let's create it again. But this time I'll use the keyboard shortcut Ctrl-T and Enter. Now we do not want to call it Table 3. So I'm going to come up here and call this TBL_MC and then Enter. So far, we have looked at how to create a table, we name the table, and we remove the table. In the next video, we can have a bit more fun making our tables look good. In this video, we're going to look at how we can customize and work with tables in Excel. In the previous video, we helped Sarah create this table, but she doesn't actually want the blue stripes, and manually changing it could take a lot of time. Fortunately, working with tables, it's really straightforward. We're going to click somewhere into our table, and in the ribbon, the Table Design ribbon comes up. So I'm going to click on that. And on the far right, we see a gallery of table designs. If you hover over that gallery, you will see a live preview. So we haven't actually selected it. We've just hovered to get even more options. We click the More button, which is the drop-down on the far right-hand corner, and there's quite a lot to choose from. So take a moment to hover over the different options and find one you like and click to select. I'm going to go for Blue Table Style Medium 16. So we can see how quick it is to make a massive change to the formatting in our workbook. But there's even more we can do. Use the Table Styles options to the left of the Table Styles. So let's say we didn't want the alternating colored rows. Excel calls these banded rows, and we can simply select it. We could instead turn on banded columns for alternating colored columns. We can also make our first column stand out. This will vary depending on which style you've chosen, but very often that has the main or unique identifier for that row, so that's quite useful. And you can make your last column stand out as well, which is great if you've got a subtotal. In this case, we don't want it, so we're going to unselect it. But the best option in this group is the total row. Can you find the total row checkbox and just put a little tick in it? And what that has done is add a total row at the bottom of our data and sum up the furthest right numeric column, which is great. So I've got my total late charge, but actually I'd really like my total invoice amount. So we're going to click into the total row, under the amount column, and we're going to click the drop down. And we're going to choose sum. And sum isn't the only function we can use. So let's say we'd actually wanted to see an average late charge. If I come to my drop down, I could choose an average. And if I wanted to count how many rows there were in the table, it doesn't really matter which column I choose. I'm going to go for payment number, click the drop down, and choose count. What's really great about the total row is when we need to add new data to the bottom of the table, we just turn it off, pop on your data in, and then we turn it back on. It will appear underneath the new data and include those new values. So making it much easier to work with our data. Another feature you may not have noticed is we are down a row 89. And yet when I said click in the payment number or the due date, you had no problem identifying the column. What we would normally see if I click out of the table is the column letters. But because we've got a table, we actually get the column headings. So another great little feature. Let's go back up to the top of our table. So I'm going to use the keyboard shortcut Control Up arrow. Another feature the table offers us is the ability to more easily select the data within the table. So up to now, when we need to select a column of data, we've been doing Control-Shift-Down arrow. But within the table, you don't need to. So let's say I wanted to select the column purchase order number. I'm not going to click into the H because that will select the whole worksheet column. And I just want the table column. So I'm going to come to just on that purchase order number and I get a tiny black arrow. And when I single click, it selects all the data. And if I click again, it includes the heading. If I now wanted to change my table and move the purchase order column to before the bank details column, it's much easier than with a normal range. Having selected the purchase order column, all I need to do is come to the edge, ensure I've got the 4-arrow move icon, and drag and drop it in before the bank details column. I have now swapped the columns without the need for copy-paste and without impacting the rest of my workbook. And when it comes to selecting table rows, it's just as easy. So for example, if I wanted to delete a few table rows and I didn't want to impact anything to the right of my table, I come just into the table and again, get that small black arrow. One click selects just one table row. And if I click and drag, I can select multiple table rows. So we've seen how we can use our styles on the table design ribbon to format our table, and we can customize those formats using our table style options. And then we saw how we could more easily select data and maybe move columns or delete rows by selecting either at the top of the table column or to the left of the table row. In the next video, we'll have a look at how easy it is to sort and filter data in a table. In this video, we're going to look at sorting and filtering data in a table. Now that Zara has the data all set up very nicely in the table, she'd actually like to start getting some information out of this data. And the first thing she'd like to know is, which was the highest invoice amount paid? One simple way of solving this problem is to sort the data by amount. If we come to the amount column at the top, you'll see an auto-filter button. And if we click on that, it gives us a selection of options for sorting and filtering. We're going to click Sort Largest to Smallest. It has sorted not just the amount column, but the entire table. And we can now see the invoice that was the most expensive. The next thing Zara wants to know is, what was the earliest invoice for Melbourne? So this time we're going to need to sort by location and date. We're going to come to the location first and we're going to say sort A to Z, which will bring Melbourne to the top. But now when we come and sort by invoice date, we will lose our sort on location if we use the auto filter buttons. Fortunately, we have another option. Make sure you've clicked somewhere in the table and now come up to your Data tab. And we're going to the Sort and Filter group. Click on the Sort button. We already have a sort by location, so we just need to add another level. And our second level will be invoice date. We do want to sort oldest to newest, because we want the first invoice date. And we're going to click OK. We have retained our sort by location, but it is now sorted by invoice date within location. So that is how we can create a more complex sort. Zara would next like to focus on just the invoices that we issued in February. For this, you'll be better off filtering the data, and the autofilter buttons we've already seen can be used to filter data as well. So we're going to come to our autofilter button, click the drop down, and there are all the values that appear in this data set. We're going to unselect all, choose just February, and say OK. Two things to point out: the sort has not been affected. If you have a look at our autofilter buttons, it is still sorted by location and invoice date, and they both have a little up arrow. It has also been filtered to only show the February data. So sorts and filters can run alongside each other without interfering in any way. The other thing worth noting is that the total row is now showing us just the totals for the February data. So they will adjust to show totals for the visible cells. Now, to clear a filter, you come back to the autofilter button, click the drop-down, and clear filter from invoice month. Zara would now like to see all the invoices that were sent in March that were over $1,000. So this time we're going to add two filters. We'll start with invoice month again. So going to click the drop down and choose March this time. But now I'm going to come to the amount and click the drop down. Now I don't want to start unselecting everything that's under 1,000. Fortunately, we don't have to. If we come to number filters, we get a fantastic array of very rich options. So we could just get the top 10, the above average, but what we want is a greater than. So I'm going to choose greater than, type in 1,000, and say OK. Unlike the sort, when we've added another filter, it does not replace the first one. It has kept the original filter, so you can build up quite complex filters just by compounding them. And we can see all of the invoices for March that are over $1,000. When you have multiple filters, to clear each of them individually would be quite time-consuming. So another option is to come back up to our Data tab and choose Clear. That will clear all the filters from within this table. Now, everything we've looked at so far, you could have done in a normal range as well. But what we're going to look at next is only available if you're working with a table, and it's called a slicer. So we're going to click somewhere into our table, and we're going to come up to our table design, and we're going to find the Insert Slicer button. Now, slicers really just another type of filters, but it's very intuitive and makes interacting with the data far simpler and a bit of fun. So we can click inside the slicer, and you can add as many slices as you have columns, but we'll just have to add one for location and one for month. And then we'll say OK, and now our two slices have been added. At the moment, they're sitting on top of the data, so we're going to move them. But first, we're going to resize them. Now, to resize them both simultaneously, if you hold your Shift key down and click on the second one, you'll see them now both highlighted. You can either drag any of the resize handles, which are the little bubbles around the edges, or if you want to be more exact, you'll notice we now have a slicer ribbon that's showing. We can come and specify an exact height and exact width. Click away for a moment to unselect the slices. And now to move them, we just click and drag them to where we actually want them to be. I'm just going to put them here on the right of the table. Coming back to our slicer ribbon, there are a few useful options. One of them is our slicer's styles. And if I click the drop down, I can add some styling to each of my slices to make them a little nicer. But now let's see how they actually work. Let's say I wanted to see all of my invoices for April in Sydney. I click on April and I click Sydney. Too easy. To clear a filter from the slicer, you just click on the top right-hand corner, the clear filter icon, and it's removed. So we've seen how easy it is to sort and filter data in a table, and how we have this fantastic additional option of using slices. In the next video, we're going to start looking at performing calculations with data in tables. In this video, we're going to look at performing calculations with values in tables. We're going to start in the supply invoice statement. And the first thing Zara would like to do is find out the total amount paid according to our supplier. So we're going to click into W1 and we're doing sum, so equals sum, tab to open our brackets, and we didn't use named ranges in here. So we're going to select our column. Remember, we can just come up to the top of the column, not the worksheet column, but the table column, and single click. And it has selected the whole thing. But what's happened over here is quite unusual. Instead of putting our usual cell references, Excel's put what's called a structured reference. And this is what you're going to get when you perform calculations with values in a table. It's quite easy to understand. It starts with the name of the table. It then has the name of the column enclosed in square brackets. And this is saying add up the values in the amount column in the table supplier. And when we press enter, we get the answer. Now, structured references are very robust. If I change the name of the table, the structured reference will update. If I remove the table altogether, the structured reference will revert back to normal references. So a little bit more robust than named ranges. Let's look at another example. So I'd like to know how many payments were made altogether according to the supplier. And for this, we're going to use Excel's rows function. So I'm going to type equals ROW and down to select rows plural. And now it's asking for a column, a row, or even a block of data. I can use the entire table. So if I just type TB and select my table supplier, it has selected the whole table. I could have chosen a column as well, but that will work fine. And when I press enter, 84 rows. And let's look at something quite interesting. The next thing Zara wants to do is find out for each invoice how many days it was since the invoice being issued and invoice being paid. So we're going to take the paid date and subtract the invoice date. We're clicking into T2 and typing equals, and I'm going to click on paid date. Couple of differences. First of all, you'll notice the table name has not been included this time. Well, I'll explain why in a moment. But the other thing that's different is it's included this @ symbol. We didn't select the whole column. We're not actually trying to work with the whole column this time. We're only trying to work with a single cell. And what that @ means is get the value in this row in the paid date column. Let's do our minus now. We're going to click on invoice date, and you'll see they get the same thing. Subtract the invoice date value in this row. Okay, we're now going to press enter. How amazing was that? It has extended the table one column to the right and copied the formula down for us. And now the only thing left for us to do is to come in and give it a sensible name. So we're going to call this Days to Pay. Just click on Cell and type the name. And now we see why we didn't include the table name, because Excel realized that this was going to be part of the table. So we have a calculation in a table. It doesn't put the table name, but where the calculation is outside of the table, it will put the table name, because obviously we might have more than one table. So it needs to be clear about which one we are using. Let's have a look at one more calculation so we can understand how these structured references work a little better. We're going to do this in the recon analysis, but we're going to use the MC data. So I'm going to click in here for a moment. Now the last thing that Zara wants to do here is find out the total overdue days and the total late charges for each of our regions, Sydney and Melbourne, and we're going to do this in our recon analysis. What we would like to do though is to create a calculation that can be dragged down and across, because our late charge column is actually next to our days overdue column, and we can do this using structured references. So we're going to start with our equals, and remember, going to need a sum ifs for this calculation. Now sum range is our days overdue, but if I used a named range, I wouldn't be able to drive the formula across. If I used a structured reference, however, interestingly, I can. So we're going to choose our table, which is table MCI, but now we need to specify a column. And rather than typing, if you just type your square bracket, look at that, all the column names actually come up. And the one we want is overdue by. So I'm just going to double click to select, and we do need to close our square bracket. Now a structured reference is a bit like a mixed cell reference. When we drag it down, it will still refer to the rows in that column, so the rows are locked. But when we drag it across, it will actually move to the next column on the right. Okay, now type a comma. The next thing we need is our criteria range, which is our location. Now we do not want this to change when we drag across. We need this to remain absolute and use our named range again. And then a comma. And then finally, our actually criteria is Sydney. So I'm going to click on A8, but again, we need a mixed reference this time when we drag across. We need it to stay locked, but when dragged down, we need it to change. So we're going to press F4 once, twice, and 3 times. We've got the dollar just in front of the A. And we can close our brackets and press Enter. Let's start with dragging the formula down, so I'm going to double click. Yep, it looks okay. And then we're going to drag across. Little tip if you come to your fill options and choose fill without formatting. You can copy your formula down without copying the formatting. Well, that's looking good, but let's just go and double check. So now double check this one and you will see that it has moved to the next column in the table, which is our late charge. It has kept the location the same and wanted this kept, the A, the same. It has changed the row. So 3 types of references we've looked at. There are structured references, which behave a bit like mixed cell references, locking the rows but not the columns. Our named range, which are usually absolute, and mixed references using our dollars there. There's no right or wrong about which one to use. It's helpful to know about all 3 and to use the one that will help you solve the problem that you have most effectively. So as well as structured referencing and calculations, we also had a brief look at how tables auto-extend. This is our first hint of the automation capabilities in tables. We're going to explore this even further in the next video. In this video, we're going to look at how easy it is to automate workbook functionality using tables. You may recall in the last week, we created a drop-down list to show location and to make it update dynamically. We used a dynamic named range. Now that worked, but the problem of the dynamic range is it's quite complex to set up, and a lot of other people who may be using the workbook are not going to understand them, so they're not always the best choice. A much easier option is to replace the dynamic name range with a table. We're going to see how we do that from scratch. So I've removed the locations named range that we created last time, and we're going to do it from the beginning. So come to our recon analysis. We're going to start with creating our simple named range. We're going to select locations down to Melbourne and keyboard shortcut Ctrl+Shift+F3 and press enter. So that's not a dynamic one, but let's check if it's working. Coming back to our invoice report, we're going to come to location, click the drop down, and there are 2 locations, so that's fine. Now the problem is a brand new city has just come on board, which is the city of Perth. And they actually just produced a last-minute invoice which Zara needs to add into her data. The first thing we want to do is add Perth into our summary data, so it's picked up in our drop-down list. To have it picked up dynamically or automatically, we're going to convert this data to a table. So click anywhere in your data, and Ctrl+T is our keyboard shortcut, and press enter. The table has been added. The banded rows do look a little bit silly, so we're just going to turn this off. Now let's see what happens when we add Perth. I'm going to click into A10 and type Perth and press enter. You'll notice the table has automatically extended. If we come and check our locations named range, it includes Perth. So as our table grew, the named range also grew. And what that means is back in our invoice report, I can select Perth for my drop-down list. Great. Now we need to go and add the new Perth record at the bottom of this data. We're going to switch our filter to April because it's an April invoice. And we want to add data at the bottom of our table. Going to switch our total row off, come back up to table design and untick total row. And now make sure you've clicked into A89, which is the first row underneath the table, and we're going to type our payment reference, which is 24888_1, and press tab. As we saw with the previous example, our table has automatically extended down, and everything within the table has extended as well. So the named ranges, the calculations, the formatting, the conditional formatting, and data validation all copy down. So it's a lot of processes being automated. Now we don't want to spend ages typing the data in. So for speed, I'm just going to copy the data in the row above, Ctrl+C, and click into B89 and Ctrl+V. Then I'm going to come into my location and I'm going to type Perth. When I tab, it automatically goes blue because that is my selected location. And over here, I was going to type 800. So we've now added our new invoice. Let's come back to our recon analysis and just see one Perth invoice for $800. So this table is automatically picking up the new values because it's also referring to the named ranges which have grown. So we've now seen that we've automated the relationship between our recon analysis and our invoice report simply by adding 2 tables. Let's take one last example, probably the most important one. I'm going to come back to my supply invoice statement. We spent a lot of time at the beginning of this course adding in formulas to clean up the data. But the data is going to come through and be replaced every month, and we don't want to have to go through all of that every single month. What we want is something that can be reused, and by putting it in the table, we get exactly that. Now, to demonstrate this properly, I'm just going to unhide those columns we had earlier. So select D and K, right-click and unhide. So there's all the data that we had to start off with. And everything from column L onwards is actually calculations to clean it up. So come next month, what we're going to do is clean out this data because it's not what we're working with anymore. And then we're going to import, copy, paste the new data into our table. How do we clean it out? Well, we can start by selecting the first row and then Control-Shift down arrow. And then to remove, we're going to either press the delete on our ribbon or Control- to actually remove these rows. So we're not just deleting the data, we're actually removing those table rows. The table is still there. It still has all the calculations, all the named ranges, but it doesn't have any data in it at the moment. When we get our new data, and I've got some demo data sheets to work with, I'm going to copy, and you can see that data is messy, just like our earlier data. When I come back to my supply invoice statement, click in the first empty row of my table, and paste, Ctrl-V. It has pasted the new data in, automatically resized the table, and automatically applied all the cleaning operations. So once you set up the table with all the formulas which become like rules in the table, you can just reuse it thereafter. So we have now automated the whole process of cleaning and summarizing our data just by applying tables. Applying tables makes it much easier to work with our data at this level, but as we start using more advanced functions like pivot tables and power pivot, they become even more important. So start thinking about how you can start using tables in your own data. So let's recap the topics you'll be covering this week. Performing logical operations with if, applying advanced logical operations, categorizing data with VLOOKUP, matching data with VLOOKUP and XLOOKUP, and then advanced data matching with index and match. You've got another great video for each topic and some challenging quizzes for you to test yourself. Don't forget to check out the toolbox as it will help you with this week's practice challenge. You're now on your way to becoming an Excel ninja.
In this video, we're going to look at performing logical operations on our data using the if function. Zara is now ready to actually start doing her reconciliation. And coming onto the Recon Analysis tab, you'll notice that there's quite a big difference between what the supplier statement is saying and what Zara's data is saying. Now she needs to work out what's causing that difference or correct the error if that's the reason. So we're going to come and have a look at our supplier invoice statement. And you'll notice that there have been some credits, but those credits are showing up as positive amounts, where really we should be subtracting them from the amount paid. So we need a calculation that will check if the type is credit, and if it is, multiply the amount by -1. Before we get into this example, though, let's look at a slightly simpler example of the if statement. So coming into our invoice report, the first thing Zara is going to do is work out if an invoice is overdue or not. And we're going to do this using our if function. So clicking into M5, we're going to type equals if and open our bracket. The first thing the if wants is a logical test. This is where you compare two values using a logical operator. So for example, I'm going to check if my payment date is greater than or bigger than my due date. That is an example of a logical test. A logical test must always use a logical operator. There are 6 you can choose from: equals, greater than, less than, greater than or equal to, less than or equal to, or not equal to. The logical test will always return either true or false. After you've put it in, type a comma, and now you need to put what you want to happen if it returns true. So if my payment date is greater than my due date, I want to see a yes in that cell, and I put it in double quotes because it's text. Then I type another comma, and the last argument the if wants is what I want to do if it's false. Well, I just want to leave the cell empty, but there's a bit of a trick to this. You need to open your double quotes and immediately close them. I'm going to close my bracket for my if so you can see it, and then press enter. And you can see all the overdue invoices have been flagged with a yes. Now that was a very simple example just using text, but instead of the text, I could put any calculation I liked, and it could be quite sophisticated. Let's look at a slightly more interesting example. So we're now going to calculate how many days our invoice is overdue by. Bear in mind, if it's not overdue, we actually want to just put 0. We don't want it being overdue by a negative amount. So again, we're going to need our if statement. We're going to start with our equals if, and this time, our logical test we're going to do slightly differently. We're going to check if the overdue value is equal to nothing. If that is the case, it means it's not overdue. So type my comma and put 0. Then type another comma. If it is overdue, I'm going to need to use my network days that we looked at in the previous week. So I'm just going to type network days. My start date is my due date. My finish date is my payment date. And don't forget to include our holidays, which is a named range. So I can just type HOL and tab, close my brackets for my network days, and close my brackets for my if. And when I press enter, it has now calculated the correct overdue days for each invoice. So there were 2 really good examples. Let's go back now and solve Zara's problem. So back in our supplier invoice statement, we're going to come to Q2, the calculation of the dollar amount, and we're going to double click. Now the first part of the calculation is absolutely fine, so we're not going to change that. But what we're going to do is take that result, and if it's a credit, we're going to multiply it by -1. If it's not, we'll just multiply it by 1 so it doesn't change. So after our black bracket, we're going to type our times, then our if, and open our brackets. Our logical test is going to be to check if our type is equal to credit. Then a comma. If it's true, we're going to need to multiply by -1. And a comma. If it isn't, we're just going to multiply by 1. Now close your bracket for your if and press enter. You'll see all the values have stayed the same except for the 2 credits, which are now negative. Fantastic! Back in our recon analysis, we've made a huge difference and are 1 step closer to completing it. So just to recap, when you need a calculation that will do different things under different circumstances, probably find that the if will solve your problem. In this video, we're going to look at how we can solve more complex logical problems using nested ifs, and we're also going to introduce 2 other logical functions called and or. Zara has been asked to recalculate the late charges. The system has changed and we're now going to charge a different rate depending on the location. If it's Sydney, we're going to multiply the amount by the overdue days by the penalty rate. But if it's Melbourne, we're just going to charge the $5 flat rate. The problem is, we now actually have 3 possible outcomes. If it's not overdue, we're going to charge 0. If it is overdue, we're going to then have to decide if it's Sydney or Melbourne. The if on its own can only handle 2 possible outcomes. So the moment you have more outcomes, you need more ifs. This is called nesting ifs. So the way it's going to work is the first if is going to check if our invoice is overdue. If it's not, we're going to charge 0. We then still have 2 possibilities. So our second if is going to check if our location is Sydney. If it is, we're going to do the calculation. If it's not, we're going to do the flat rate. So let's see this in action. So we're going to start by clicking into O5 and typing equals, if, and tab. Now the first thing we're going to check is if we're overdue. So we're going to check if overdue is equal to nothing. In other words, it's not overdue. If this is the case, well, we're going to charge 0 late charge. So nice and easy. Now type a comma. We now have 2 more possibilities, so we're going to need another if. We're going to type our if and tab to open the brackets. Our logical test this time is going to check if our location is equal to Sydney. Then our comma. If it is, we're going to need to take our amount, multiply it by our overdue days, and multiply that by our penalty rate. Then type a comma. If it's not Sydney, there's only one more possibility. It must be Melbourne, and we're charging them the flat rate, which you may recall we have a named range for. Now we can close our bracket for our second if, and very important, close your bracket for your first if. If you now press enter, late charges all corrected. You can nest up to 64 ifs, but let's hope you'll never need to. There's one more potential limitation for the if. It can only process a single logical test, but sometimes we need to check multiple things. So in the next example, if the invoice is overdue and it is more than $500, Zara needs to take some action. But here there are 2 things we have to check. Now the functions that can help us with this are the and the or function. Both are designed to evaluate logical tests, and both of them can evaluate up to 255. The and is the fussy one. If all of the logical tests are true, the and will return true. If even one of them are false, it will return false. The or is a little bit more relaxed. As long as one of the logical tests is true, it will return true. Now for our example, we need the and. So we're going to click into P5 and type equals and open our brackets. The first logical test is going to be, is our invoice overdue? And we'll use our overdue days as time. So I'm going to check if overdue is greater than 0. Then type a comma. Our second logical test is going to check if our amount is greater than or equal to 500. This will also include amounts that are equal to 500. And then we're going to close our brackets and press enter. You'll see we have got a few trues where both conditions are met, but most of them are returning false. If we'd used the or, we would have found we got a lot more trues because just one of the conditions would need to be true. Now the thing with the and the or is they only return true or false, and if that's what you want, that's great, but that doesn't look amazing. Zara would actually like to see the word action if it's true and nothing if it's false. So what we're going to do now is nest our and inside an if. So coming back to P5, we're going to double click, and just after the equals, we're going to slip an if in there. The logical test has already been done by our and, so we're just going to type a comma after that red bracket. If the and returns true, Well, we need to take some action. If it doesn't, we can leave the cell empty, which is open quotes, close quotes. Now close your brackets for your if, press enter, and we can instantly see our actionable items. So just to recap, if you have more than 2 outcomes, you may need to look at using nested ifs. On the other hand, if you need to evaluate logical tests, you can use the and, the or a combination of the two. In this video, we're going to look at Excel's VLOOKUP function and how it can be used to categorize data. This is not the most typical use of this function, but it is exactly what it was designed to do, and it does it very efficiently. Coming back to our scenario, Zara has convinced the supplier to simplify their late charge penalties. So they're now going to be the same for Melbourne and Sydney, and instead they're going to be charged on a series of flat rates depending on how overdue the invoice is. So Zara's noted them in the workbook, and you'll see 1 to 4 days gets charged at $2.25, whereas 5 to 9 days will be charged at $5.50. So she now needs a new calculation that will look up the appropriate penalty. In the previous video, we saw how we could solve this problem using a nested if. We would, however, need 4 ifs. This would create a very complex and inefficient formula. The clue is in the language. We're not saying if it's this, do that. We're actually saying look up the appropriate penalty. And where that's the case, you're better off using a lookup function. One of the most widely used lookup functions is the VLOOKUP, and it is perfectly suited to this type of problem. It does have quite a few arguments though, so we're going to break it down with a very simple analogy. What does the VLOOKUP do? Well, imagine that you have somebody's name, but you need their telephone number. You will go to the telephone directory, you will find their name, and then you will be able to get their telephone number. That process of looking it up, the VLOOKUP automates it. So when we use the VLOOKUP, the first argument it's going to ask for is a lookup value. That's the piece of information you know, the person's name. The second argument is where you're going to go and look it up, the telephone directory. The third argument says, okay, when you find the match, if there's more than one piece of corresponding information, which one do you want to get back? So if there was a telephone number and an address, we'd need to specify which one we wanted. And finally, we have the option to choose whether we want to do a range lookup, that's looking within a range, or an exact match. In this first example, we're going to be doing a range lookup because we're not trying to find an exact value. We're trying to find something between 1 and 5 or between 5 and 10, for example. Let's see how it works. So clicking back into 05, I'm going to type equals and VL. Now the V is for vertical, so you can only use the VLOOKUP if your lookup data is organized vertically. If it isn't, you'll have to use HLOOKUP. Now I'm going to press Tab, and my lookup value, the thing I know, is my overdue by. So I'm going to click onto that and type comma. My lookup table is my new penalties table, and I'm going to select the whole table, but not the heading. And now really important, we haven't named this range, so I'm going to have to press F4 to lock it in place and make sure you get both sets of dollars. Now I'm going to type another comma. The VLOOKUP is going to always match our lookup value into our first column of our lookup data. But it's quite possible there will be multiple columns within the table, so we need to specify which column has the value we want to get back. And in this case, it's the second column in our lookup array, so we're going to type a 2. VLOOKUPs are by default range lookups. So if you're doing a range lookup, you don't have to worry about the last argument. We can just close our brackets and press enter. And there are all of our late charges corrected. So the VLOOKUP function can easily be used for categorizing data. This could be working out which tax bracket somebody fell into or grading your student results. The only thing to bear in mind is that your lookup data must be sequenced smallest to largest. In the next video, we're going to look at a more typical use of the VLOOKUP, which is when we need to match data. So keep watching. In this video, we're going to look at how we can use VLOOKUP to match data exactly, and we're also going to take a peek at the brand new XLOOKUP function. So coming back to the reconciliation, Zara has identified that in our NCI report, there are 84 invoices, whereas if we check our supplier statement, there are actually 85. So we know there's at least one record in the supplier statement that is not in the MC report. What we need to do is find out which one, and probably the easiest way to do that is using a VLOOKUP. Now, just coming back to our MC report for a moment, when we do the lookup, we're going to use the whole table. We're going to match the customer reference to our payment reference, which is in the first column, and we're going to get back the amount, because as well as identifying which record is missing, we're also going to double check that all the amounts match. Now, to save us counting later on, the amount happens to be the 10th column in this data set. That is something you will need to check before doing your VLOOKUP. So back in our supplier statement, we're going to click in U2 and type equals VL and tab. Our lookup value, the thing we're going to match, is our customer reference, and we're going to match that into our table MC and a comma. Our column index, the column we want to get the value back from, is in the 10th position in that table. And now the most important thing for the exact match, we have to specify it's an exact match. Now it's strange, we choose false. What that means is it's not a range lookup. So you can either do that, or if you get tired of doing that, you can just put a 0. They work the same in VLOOKUP. And when we press enter, we can straight away see that the first record doesn't have a match. That NA is not really an error, it is just telling us that the VLOOKUP couldn't find a match. Now on closer inspection, you'll see that this invoice was paid in March, and we're only trying to process invoices that were paid in April, so that shouldn't even be on the list. We've just identified and solved another part of the problem. What we do want to double check though is that all of these amounts actually match. And the easiest way to do that is to just add a little bit to our calculation. So I'm going to double click into U2, click after the equals, and we'll take the amount in our supplier statement and subtract the amount in our MC report. And you can see most of them are 0, which is what we would expect, but we do have one anomaly, which is going to need a little more investigation. Before we get into that though, with a recon, it's always a good idea to match both ways, because there could be information in the MC report that's not in the supplier statement. So we could do another VLOOKUP, but we would need to create a named range or something, because you'll notice the customer reference is not in the first column in this data set. VLOOKUP also has a few other limitations, and one function that can help us get around these limitations is the XLOOKUP function, and that's what we're going to look at next. Now, the XLOOKUP doesn't look up entire tables, it just works with individual columns or rows. So it's easy if you name them first. You'll see we have already named our customer reference, but we haven't named our amount column. So remember, we're going to come into our table, click once at the top of the column, click a second time to include the headings, and then to create our named range using Create from Selection, we're going to press Ctrl-Shift-F3 and enter. Okay, both our columns named. Let's come into our invoice report and we're going to click into Q5. And we're going to type equals XL for XLOOKUP and tab. Now the XLOOKUP does not have to work vertically, it can work horizontally or vertically, so already an advantage. The lookup value is exactly the same. We're going to click on our payment reference and type a comma. But now the lookup array is a single row or column. So we're going to match that payment reference into our customer reference and comma. The return array, we don't need to specify the column number within a block of data. We can just refer to the array directly. So that's actually a little easier and a lot more flexible. And our return array in this case is our amount. And comma. The XLOOKUP also gives us a few other options. So if it doesn't find a match, rather than bringing back an NA, we can specify what value we'd like to get back. And actually, we'd prefer to get a 0. So I'm going to type a 0 and then comma. As well as specifying exact match, you can specify whether it brings back the next smaller, the next larger, or you can even use a wildcard character, like an asterisk, to get back something similar. Well, we want an exact match here, so I'm just going to type 0. And then there's one more optional argument. You can actually specify your search order. And well, we're happy with first to last, so I'm going to pop a 1 in there, close my brackets, and press enter. And you can see the XLOOKUP has done the job, same job as the VLOOKUP, but it doesn't matter which sequence the columns are in, and if they actually move, as long as you've named them, you're not going to have a problem. So actually maybe a little more intuitive and definitely a lot more robust. Now let's make the same change to this calculation as we did previously. So I'm going to double click into Q5 and I'm just going to take the amount from this sheet and subtract the one from the supply statement. And again, we have one anomaly. Now, if you don't have the newest version of XLOOKUP, you might not have been able to do that, but it's good to see how it works because hopefully you'll get that function really soon. For your homework, I'm going to ask you all to try and repeat what we've just done, but using a VLOOKUP instead, so you get that additional practice. The solution file will contain the VLOOKUP, not the XLOOKUP, so you can check you've got it right. In the next video, we're going to look at an even more powerful lookup function that's available to everybody, so don't worry if you don't have the XLOOKUP at this stage. In this video, we're going to look at two really versatile lookup functions called the index and the match. We are going to help Zara finish off a reconciliation, but to begin with, I'd like to start with a slightly easier example. So if you'd like to follow on, please make sure you have 155 index match examples opened up. In this example, we would like to look up the population for Algeria. If you have a look at the population column, you'll see the population for Algeria is in the 3rd position. Now this gives us a clue as to how the index function works. If we come into B4, we're going to type equals IN and tab. The first argument the index function requires is an array. Now this array can be a column or a row, so the index function will work both vertically and horizontally. In this case, our array is the population column, and I've named it, so we're just going to type POP and tab to select. Then we're going to type a comma. The next argument that the index requires is a row number. In other words, the position within that array. And we can see that Algeria's population is in the 3rd position. So I'm going to type a 3 and press enter. Too easy. There's our population for Algeria. So pretty straightforward really, except one small problem. If I come to Algeria and I actually change this, so it's on a drop-down list, and I say, actually I want the population for Angola, you'll see it's not changing, and that's because I actually typed the 3 in. So obviously we need a way of automating the process of determining the position. What I want to do is take the selected country and match it into my country data and return the position at which that country is found. So in other words, I'd like Angola to be found at position 5. Now the function that can help us with this is the match function. Click into C4 and we're going to type equals M and tab for match. Now the match is similar to a VLOOKUP in a way in that the first thing it wants is a lookup value. And our lookup value, the thing we're going to use to match, is our country. So click on A4 and type comma. We then need to provide it with a lookup array. But unlike the VLOOKUP, with the match, it can only be a single column or a single row. But again, it can work horizontally or vertically. Here, we want to match it into the country column, and I've called it CTRY, so I don't need to compete with all the counts. And then I'm going to type comma. And the last thing we need to provide is whether it's a range lookup or an exact match. And of course, this is an exact match, so we type 0, and then we press enter. And as we would expect, it's found Angola at position 5. So now all we need to do is somehow combine our match with our index. And I'm going to show you a really easy way. I'm going to double click back into C4 and select everything except the equals and copy Ctrl+C, then press escape. Then come back into B4, double click, and we're going to replace this 3, so I'm going to delete it, with our match, so paste Ctrl+V. What will happen now is the match will look up the appropriate row number, and then the index will return the value in that position in the population column. So when I press enter, there's my population for Angola, and if I come to my country selection and I choose Australia, there's my population for Australia. So while the index and match can work independently and can even be combined with other functions, we do typically find them working together. But that's not all we can do. The index will actually allow us to look up in 2 directions at the same time. To demonstrate, can I ask you to come to the next sheet, which is called 2? And here we're going to extend our example. Previously, we only worried about returning the population, but it's possible we could want to also get back the capital or the currency. And you'll see I've actually got this value on a drop-down as well. So we don't have to just get back population. The thing, though, is we're now going to not only have to determine which row the value is in, but also which column. So we're going to need another match. Now, we've already got a match function created for us in C4, returning our row number. What we're going to do is click into D4, and we're going to type equals M and tab to start a second match. The lookup value this time is the column header for the value I want to get back. So I'm going to click on population and type comma, and then I'm going to match that into my other column headings. And again, this is an exact match. And it'll find capital position 1 and population in position 4. So I press enter, and there's my column number. All that's left to do is to create the index function that will use this row number and this column number. So we're going to click into B4 and type equals IN and tab. Our array this time, however, is that whole block of data. So I'm going to start from B7 and drag to E7, and then press Ctrl-Shift down arrow to select all the values. I'm just going to scroll up so you can see what I'm doing. And I'm going to type a comma. The next argument the index needs is the row number. Now we could type the match in here, but you don't have to if you've got it sitting in another cell, which we do. So we're just going to click into C4. If you are only doing a one-way lookup, you only need to provide 2 arguments. But we're doing a 2-way lookup, so we're going to need to give it that column number as well. So we're going to type a comma. And we've got our column number calculated here. So I'm going to click on D4 and press enter. So there's our population for Algeria. But if I come and change population to be capital, there's our capital for Algeria. And if I click on Algeria and change that to Australia, there's our capital for Australia. So really powerful 2-way lookup there using an index with 2 matches. Now you understand the principles, let's go and finish off that reconciliation. So I'm going to minimize this, and we're back in our recon. Now you may recall from the last video that there was just one problem left, and that was this record where the amounts paid according to the supplier were different to the one on our report. Now Zara's looked at the data more carefully and noticed that this customer reference number is actually a duplicate of another, which can't be right. What she'd like to do is return the correct reference number from her system, and she can do this by matching the purchase order number in this report to the purchase order number in her MC report. So she's going to match the purchase order number into this column, and when she finds it at this position, she wants to get back the appropriate payment reference. She can't use a VLOOKUP to do this, however, because the purchase order number is to the right of the payment reference. She can, however, use an index match. So that's exactly what we're going to do. Back in our supplier invoice statement, we're going to click into V2 and we're going to type equals IN and tab for index. Our lookup array is the payment reference column on the other sheet. So we're just going to type PAY, down arrow twice and tab because it's named, and comma. But now we need to match our customer purchase order number. So I'm going to type MA and tab. I'm going to click on the customer PO. And I'm going to match that into the purchase order column in the other sheet. So PO and tab to select PO number. Don't forget to make it exact, otherwise you get random wrong results coming back. Close the bracket for your match, close the bracket for your index, and press enter. And Zara was completely right. The payment reference should be 24674, not 673. So we're just going to come in here and replace that 3 with a 4 and press enter. It is now pulling back the correct amount and everything is balancing perfectly. So we've seen how the index and match can solve problems that maybe other lookup functions can't. There is a little bit of a learning curve involved, but the good news is we've given you another great practice challenge to go and practice all these new skills. So don't forget to check it out.